Today we're going to talk about dividing a little bit differently with polynomials. Instead of doing long division, there is a shortcut we can use. It's called synthetic division. So that is what we're going to talk about today. Now, synthetic division can only be used in certain occasions. Synthetic division can only be used when what you're dividing by has a degree of 1 or is linear. So if we divide by an x squared, an x cubed, an x to the fourth, we cannot use this method, only when we divide by x. So the basic process is the following. First, what you're going to do is you're going to set what you're dividing by equal to 0 and solve. So I'm going to set x minus 2 equal to 0, add my 2 over, I get x equals 2. Once we have that, that will kind of take care of the drawing the line and changing our sign that we do with long division. Now what I do is I make an upside down division sign or symbol. Now this division problem is going to take up 2 lines, so be careful when you're finding your answer. So now what I do is I take the 2 that we just found and I put it on the exterior in the first line of my synthetic division. Once I've done so, I start filling in the inside of my division problem by using only the coefficients in front of the variables. I need to also make sure that my original polynomial that I'm putting inside is in order, which it is. So x to the third is a 1x to the third. Minus 3x squared is a negative 3. Minus 7x is a negative 7. And then plus 6 is a positive 6. Now, if you notice, I did not list any of the variables with it. That's why it's called synthetic. It's a little bit different. The process is as follows. The first digit that you wrote, the leading coefficient is going to come straight down. Then you're going to multiply that 2 you have out in front by what you just dropped down. So 2 times 1 is 2. And I write that underneath my second digit. I add down. Negative 3 plus 2 is negative 1. I repeat the process. I take that negative 1 times that blue 2 that's up front there. So negative 1 times 2 is negative 2. I add down. I get negative 9. I take that negative 9 times that 2 that's out in front to get negative 18. I add down, I get negative 12. Now the number at the end is basically our remainder. We took an x to the third and divided it by an x. So what I'm left with is 1 power less than what I started with. Since I started with the third power, when I list my answer, I'm going to start with the second power, or squared. So 1 becomes 1x squared, or just x squared. Negative 1 becomes negative 1x, or negative x. Minus 9 is our constant. Now you could do plus a negative, or you could do minus, because it is a negative 12. 12 over what I divided by. Now notice I'm not putting the 2. I'm going to put what I originally planned on dividing by, x minus 2. And that is the basic process of synthetic division. So let's try another one now when we're missing some of the terms. Example 2 says 2 to the fourth minus 1 divided by x plus 3. So just like before, I make sure what I'm dividing by is linear, which it is. So I set that value equal to 0 and solve. So x plus 3 equals 0. I subtract my 3 over, I get x equals negative 3. So now I'm going to use synthetic division. So I set up my 2-line division. I put what I'm dividing by on the outside, which is a negative 3. Now I fill in all my coefficients. So my biggest degree is the fourth, is a quartic, so the number in front is a 2. Now I do not have an x to the third, so we're going to put a 0 in there. I do not have an x squared, so I place a 0. I do not have an x, so I place another 0. But then I have minus 1. So now I have every power accounted for. My 2x to the fourth, my x cubed, my x to the squared, my x, and then my constant. Just like before, we always carry down the first leading coefficient, which is a 2. Negative 3 times 2 is negative 6. Add down, we get negative 6. Take that negative 6 times that blue negative 3 you have out in front, and you get 18. 0 plus 18 when I add down is 18. 3 times 18, 4 carry my 2 is negative 54. Add down, I get negative 54. 54 times 3, 4 times 3 is 12, carry my 1, so 162. Hopefully I did my math right. Add down, I get 161. So my remainder this time is 161. I started with x to the 4th. Now you could start with an x to the 3rd or an x squared. I started with x to the 4th, so now my leading term is going to be an x to the 3rd. So 2x to the 3rd minus 6x squared plus 18x minus 54. You know you've done it right if that last number is your constant. Then I have a positive 161 when I divided by x plus 3. So there are 2 examples. I'd like for you to try the next example on your own, pausing the video until you come up with the answer. Welcome back. I'm going to show you how to do the division. So you set x minus 1, and you should have set it equal to 0. Solved, and you got 1. We went 2x to the 3rd for my first value. Now I don't have an x squared, so I'm going to put 0 in. I have a negative 1x and a negative 7. I bring my first leading coefficient down. 1 times 2 is 2. I add down, I get 2. 1 times 2 is 2. I add down, I get 1. 1 times 1 is 1. Add down, I get negative 6. Here's my remainder. Since I started with x to the 3rd, my problem is now going to be x to the 2nd. So 2x to the 2nd plus 2x plus 1 minus 6 over x minus 1. Did you get it right? If so, you kind of understand now how to do synthetic division. Now, synthetic division can be used for multiple things, not just for dividing. It can actually be used to evaluate a given polynomial. Now, in the past, to evaluate a polynomial, what we would do is we would take our function. Every single time we saw an x, we take whatever number they gave us and put into the problem. Now, this theorem states if a polynomial function is divided by a linear polynomial, then the remainder is actually the answer to the problem. So the remainder is actually your y value. So let's try a couple. Before, if I was going to do this problem, I would say, okay, it says use synthetic division to evaluate. So what I would do is everywhere I see an x, I would put an x in this problem. So the first value they want us to find is f of a negative 4. So then what I would do is I would take my calculator and I'd say 5 times negative 4 in parentheses to the 3rd minus parentheses negative 4 parentheses squared plus 13 parentheses negative 4 parentheses plus 29, and hopefully it would evaluate, or I'd have to do it by hand. Now what this rule says is I can find this answer by using synthetic division as well. So if I put my negative 4 in front, I can take all my coefficients, just like we did before with synthetic division. The only difference here is my answer is not going to be the entire polynomial. It's just going to be the remainder. It's just the value you get when you plug in the number. So my first number comes down, I get negative 20. When I multiply, I get negative 21. Negative 4 times negative 21 is 84. Add down, I get 97. We've got to do a little math. 97 times 4 8, carry my 2, 36, 38. So 388, but it's a negative. Well, let's see, 388 minus 29. Use your calculator if you're not using your brain. Get 359, but since it's a negative, it's negative 359. What this means is that when I take my function f of negative 4, I put a negative 4 in, the answer is going to be a negative 359. Now, don't freak out. These are going to be big numbers sometimes. Let's try another one. Given the function 5x to the 4th plus 2x to the 3rd minus 20x minus 6, evaluated at x equals 2. So once again, I could take my calculator, plug them in all the times, and hopefully do the math and get the right answer. Well, I'm just going to do synthetic. So I'm going to substitute a 2 in the problem. So 5, 2, I'm missing my x squared, so that's 0. X is negative 20. And then I have negative 6. Bring down my first, 5. You should get pretty fast at these. 2 times 5 is 10. Add down, we get 12. 2 times 12 is 24. Add down, we get 24. 2 times 24 is 48. Add down, we get 28. 2 times 28 is 56. Add down, we get 50. So what in the heck does that mean? That means that if I take my function and I use my calculator and plug it in, if I substitute 2 into that entire math problem, I get 50 as an answer. Now, hopefully this has been helpful with the remainder theorem. I'm going to put one last one on the board. I want you to try it. So give this a shot. Pause it. Hit play when you're ready to move on. Welcome back. I thought you figured out probably the last one, so let's see if you did it right. So I'm going to put a negative 1 on the outside. I'm going to do negative 1. Now I'm missing x cubed, so I'm going to put in a 0. I got 2x squared, I got a negative 2, and I don't have a number at the end, so I do have a number at the end, 7. Now if I didn't have a number at the end, I would put a 0 in there. First number comes down, we get a negative 1. Negative 1 times negative 1 is 1. Add down, we get 1. Negative 1 times 1 is negative 1. Add down, we get 1. Negative 1 times 1 is negative 1. Add down, we get a negative 3. Ooh, something different. Negative 1 times negative 3 is 3. Add down, we get 10. So basically, if you took this function and you substituted in a negative 1 and evaluated it, you would get 10 as an answer. Hopefully you got this answer. So this is a review of how to do synthetic division and the remainder theorem.